Hello students, welcome back to the last session of our syllabus and where we are going to complete the HVAC subject today, and the topic is air conditioning systems with controls, temperature, pressure and humidity sensors, actuators and safety controls. So it is actually a very big topic. I have made it into a very simple way, and you can write the same way what I am presenting here in the exam. So we will see the last topic of fifth unit as well as our subject. So this is the content, air conditioning loads of fifth unit. So this is the last. Now we are standing here to complete this topic. So temperature sensing and control in air conditioning systems. So importance of temperature control in HVAC. The objectives are maintain indoor thermal comfort. So typically 22 degrees Celsius to 26 degree Celsius. Enhance energy efficiency of cooling systems. Prevent overcooling or overheating. So ensure safe operation of equipment. So key zones of temperature control are room zone control, supply air control, return air control. We have chilled water outlets, inlet monitoring. So these are the key zones of temperature control. They are room zone control, supply air control, return air control, chilled water outlets, inlet monitoring. So these are the key zones where we are going to work on HVAC systems. Types of temperature sensors used in HVAC. There are n number of sensors available. I have listed very few and important sensors, and its working principle and its construction is actually beyond our syllabus. But you can refer the books like the AK Ghosh, that is instrumentation and control by AK Ghosh. That is a very good book. You can refer for additional information, but for our syllabus and in exam point of view, so this content will be more than enough. So thermistors, so there are actually two types of thermistors, NTC and PTC. Negative temperature coefficient thermistor and positive temperature coefficient thermistor. So thermistor is normally a resistance type temperature detector. So working principle is very simple. Resistance changes with the temperature. So in case of NTC, resistance decreases as temperature increases. In case of PTC, positive temperature coefficient type thermistor, the resistance increases as the temperature increases. So its equation is R of t equal to R naught into e to the power beta into 1 by t minus 1 by t naught. So R naught is resistance at reference temperature T naught. Beta is material constant. So applications are wall mounted room sensors. So these are used in wall mounted room sensors, and AHU, the air handling unit duct return air sensing. So next is RTD. So it is also another very important type of temperature detector. It is room temperature detector, resistance temperature detector. The principle is resistance of platinum wire PT100 increases linearly with temperature. The equation is RT equal to R naught into 1 plus alpha T, where R naught is 100 ohms typically at 0 degrees Celsius, and alpha is 0.00385 per degree Celsius, and its features are high accuracy. It is very highly accurate instrument, stable and repeatable. The chiller loops, coil outlet, high precision applications, these RTDs are used. It is also a resistance type temperature detector. Then we have thermocouples. It is made up of two dissimilar metals. It works based on Seebeck effect. The principle is a Seebeck effect. A voltage is produced across two dissimilar metals when there is a temperature gradient. So voltage is produced when the two metals are at different temperatures. Then the junctions of these two material joining will produce there will be voltage will be produced across that junction, and voltage output V equal to alpha into T hot minus T cold, and features wide temperature range, moderate accuracy, used for compressor discharge and refrigerant line monitoring. Types of temperature sensors used in HVAC: IC based sensors. That is, there are many ICs available. Even they can be used directly as temperature detectors. So LM35 and TMP36, these are the few examples of IC based sensors. Linear analog voltage is LM35, that is 100 millivolt per degree Celsius. Features of IC sensors are small in size, easy microcontroller interface. We can interface with any controller. Used in embedded HVAC controls, rooftop units. So sensor mounting and placement guidelines. So here room, so sensors can be placed in different ways. So location: room wall, so that is duct space, return duct, chilled water pipe, compressor discharge. The purpose of room is occupant zone. It is normally occupant zone temperature. The sensor can be thermistor. Supply duct, delivery air temperature, RTD can be used. Return duct, feedback for room temperature, RTD, and thermistor can be used. The chilled water pipe coil temperature regulation, RTD, can be employed. So compressor discharge safety monitoring, a thermocouple can be used. Signal conditioning. So signal conditioning is very important process here, as signal conditioning is nothing but the whatever output produced by the earlier sensors what we have seen, RTDs, thermocouples, and we have thermistors, they produce the EMF. So that is normally an analog type of signal or voltage. So that should be transformed into digital form in order to display on a 7 segment display or in any recording purpose. So the signal conditioning is very essential here. So need for signal conditioning: temperature sensors produce signals that are analog, non-linear, small magnitude thermocouples in terms of EMF. So methods can be the thermistor, the linearization, log amplification, filtering. So RTD, Wheatstone bridge and amplification. Thermocouple, cold junction compensation and amplification. IC sensors, ADC conversion for digital control. So these are the signal conditioning processes. We can do this, and for referring for additional information, students, you can refer the Linear Integrated Circuits by Rai Chaudhary. Rai Chaudhary, it is a very good book. You can refer for signal conditioning processes. So control strategies for temperature regulation. So one is very simple, binary, just on or off. And logic is, if temperature is set point, compressor is on. If temperature is greater than set point, lesser than set point, so minus delta T, then compressor should go off. So advantages are simple, low cost. Disadvantages is overshoot, short cycling, and proportional control. So this is another mode of control, proportional control, that is ut equal to kp into et. So et equal to t set minus t measured. Output is proportional to the error. So proportional plus integral plus derivative, it is known as, and also it is a very popular type of control strategy, that is PID control. So equation is ut equal to Kp into Et, and it is plus Ki integral of Et dt plus Kd det by dt. So P is immediate correction. So P is used, that is proportional correction. It is immediate correction. I is eliminate steady state error. I purpose. Integral is for steady state error elimination, and D is predictive damping. So D is the differential factor is the predictive fact damping, and tuning methods are Ziegler-Nichols, trial and error, and auto tune in P in case of PLCs and BMS. PLC is nothing but programmable logic controller, and BMS is nothing but building management system. So actuators for temperature control types, there are many actuators available, and I am listing very few here. These are enough to write in the exam. So actuator type: motorized valve damper actuator VFD, variable frequency drives, and the controlled element are chilled water coil, mixed supply air damper, compressor or blower. The functions are: the motorized valve modulates cooling effect. So damper actuator controls airflow temperature. VFD, variable cooling or airflow. So application example: chilled water valve. So here input is PID, output from RTD in supply duct, and output is modulating valve positioning. So that is 0 to 10 volts signal. So result from this system is adjust chilled water flow and affects coil temperature. It affects coil temperature. System diagrams and layouts. Temperature control loop AHU. So here the room temperature is controlled by measured by RTD, controlled by PAD, and controlled by actuator, chilled water valve, coil, and finally we have airflow. So case study: VAV system temperature regulation. So VAV terminal unit the receives set point via BMS, and RTD measures zone temperature. Damper actuator adjusts airflow based on PID control, ensures occupant comfort and energy savings. The emerging trends in this area are the wireless temperature sensors, that is retrofits large buildings, IoT based HVAC control, remote monitoring, predictive control. AI based tuning is dynamic PID tuning using ML algorithms, machine learning algorithms. So temperature sensing is critical in AC systems to maintain comfort and efficiency. Variety of sensors, thermistors, RTDs, thermocouples are used for different zones, and signal conditioning ensures compatibility and control systems. So PID controllers provide precise regulation through actuators. So modern trends integrate wireless and AI for better energy optimization. So pressure sensors in HVAC systems, need for pressure monitoring applications, monitoring refrigerant pressure in compressors. It is very important. So pressure should be maintained at optimum level. Measuring duct static pressure for airflow regulation, filter pressure drop monitoring for maintenance, safety interlock using high-low pressure cutouts, and we have types of pressure sensors are board-on tube, strain gauge, piezoelectric, MEMS sensors, diaphragm type. So operating principles are board-on tube, mechanical deformation of tube, and strain gauge, resistance change due to deformation, piezoelectric, voltage generated from mechanical stress, MEMS sensors, capacitive or piezoresistive micro sensors, diaphragm type, deflection of membrane. So here the boron tube is used for the refrigeration systems, pressure gauges, whereas strain gauge, refrigerant discharge, suction lines, whereas piezoelectric, dynamic pressure sensing are pulsations, the MEMS sensors, duct pressure sensing, comfort controls, diaphragm type, VAV systems, filter status detection. So strain gauge pressure sensing and its sensor working is: the diaphragm is bonded with resistive strain gauges arranged in a Wheatstone bridge, and the formula is delta R equal to RGF into epsilon, and epsilon equal to delta L by L. It is the strain, lateral strain, and where delta R is change in resistance, GF is the gauge factor, and the epsilon is strain. Delta L is change in length of the gauge. So applications in HVAC, duct static pressure control measured using MEMS or capacitive pressure sensors, and maintains air distribution by modulating fan speed or dampers. Typical set point is zero point 0.8 to 1.2 inches in a water gauge. So filter monitoring, pressure sensors measure pressure drop across filters. It if drop exceeds threshold, alters for the alerts for filter replacement. So compressor safety is also very important. High low pressure switches disconnect compressor on unsafe values, ensures refrigerant integrity and avoids compressor burnout. So integration with controllers. So sensor output 10 to 20 milliamp or 10 to 10 volts. So controllers can be PLCs, BMS, and digital thermostat. We have the action modulate VFD for fans, the trigger safety shutdowns or generate alarms. So significance of humidity control here, the target range is comfort, the RH, the humidity is very important factor in HVAC systems. It should be, we have seen in IAQ principles also. So it is 40 to 60 is comfort RH, and lesser than 30 RH, it may be dry air, even skin irritation will occur. 70 percentage and more is mold growth, condensation and discomfort. And HVAC functions dehumidification via cooling coil, humidification via steam and spray injection, control of latent heat load and air quality. So types of humidity sensors, there are actually four types, and they are capacitive type, resistive type, psychrometer. We have thermal conductivity. So operating principle is change in dielectric constant with RH. Accuracy is plus or minus 2 percentage of RH. In room and duct mounted sensors, it can be used as room and duct mounted sensors. Resistive type, so ionic conductivity of polymer increases with RH. So that is plus or minus 3 percentage of RH. It is used in embedded controllers. And the psychrometer, it wet and dry bulb measurement. It is done manually. It ranges from plus or minus 2 to 5 percentage of RH. And calibration reference labs, it is used there. And thermal conductivity type, the change in thermal dissipation by water vapor, it is plus or minus 1 to 2 percentage of RH. Precision sensing labs. So capacitive humidity sensors. So capacitive humidity sensor, its working principle is the dielectric layer absorbs moisture. Capacitance changes as dielectric constant varies with the RH. So the capacitance change is equal to epsilon R epsilon naught into A divided by D. So any of these parameters can be varied, and there will be change in capacitance, and that is directly proportional to the change in temperature. And ER is relative permeability. It varies with RH, relative humidity, and E naught is permittivity of vacuum, and A is area of plates. So distance between plates, D is distance between plates. And sensor mounting guidelines here, for written air duct, the measure RH of room air. And supply air duct is ensure air delivery at correct relative humidity. And AHU mixing box maintain proper enthalpy. Humidifier feedback prevent over humidification. So control methods for humidity. Dehumidification uses cooling coils to condense moisture, controlled via chilled water valve. And humidification, steam or ultrasonic humidifier is activated when RH is lesser than set point. So controlled via PID or hysteresis logic. So control logic example is if RH is greater than 60 percentage, increase coil cooling and rise fan speed, and if RH is lesser than 40, activate humidifier and maintain set point RH. So this is the control logic. And signal conditioning and output. So 0 to 10 volts, so analog input controllers and BMS, and 4 to 20 milliamps, so long distance transmission noise immune, and digital IC2C SPI. So IC2 and SPI are communication protocols, and IoT in and embedded systems. It is used in IoT and embedded systems. So emerging technologies in pressure and humidity sensing. So technology MEMS pressure sensors benefits compact, integrated, fast, and example use case is VAV duct static pressure, wireless humidity sensors, flexible placement, IoT control, smart buildings and retrofits, multi sensors T plus RH plus P, cost effective combined control, rooftop units, packaged AC. So points to remember here are the pressure, the sensor type, MEMS strain, application in HVAC, duct compressor filter, control action, fan, VFD, compressor and cutoff. So humidity sensors type is capacitive or resistive type, room AHU ducts, humidifier on off control. Actuators and safety controls in HVAC system. So this is the last topic in the last unit. And role of actuators in HVAC system is an actuator is a mechanical or electromechanical device that receives a control signal. It can be in analog form or in digital form, converts it into physical motion. So it may be in terms of linear motion or rotary motion, and performs actions such as modulating flow, adjusting dampers, or controlling valve positions. So classification of actuators: electric, pneumatic, hydraulic, stepper, servo, thermal. So motion type: rotary, linear, rotary, linear, and input signal 0 to 10 volts or 40 to 20 milliamps. Compressed air in case of pneumatic, hydraulic pressure, and stepper motor digital pulses, thermal temperature. So these are the input signals common use in HVAC: dampers, valves, large air handling dampers, industrial HVAC systems, precise modulation, VRV systems, thermostatic radiator valves. So these are the common uses or applications in HVAC systems of actuators. So key actuator applications: actuator, motorized valve, damper valve, inverter drive. So controlled element is chilled water valve, air damper, compressor or fan respectively, and functions are control cooling capacity, controls air volume or mixing, control speed, variable control airflow. And then we have working example: motorized chilled water valve. So here system components are sensor, RTD measures supply air temperature, controller PID compares measured and versus set point, actuator motorized valve modulates water flow, PID output valve position, that is in terms of percentage of opening of valve, and cooling coil temperature. So control signal types are analog voltage, current loop and digital, and range for analog is 0 to 10 volts, and current loop is 40 to 20 milliamps. Digital is PWM, pulse width modulation, Modbus. Typical use: proportional position control, long distance noise immune control, and in case of digital, advanced systems and BMS integration. Integration with BMS and controllers. So here actuators are linked to DDC, direct digital controllers, or PLCs. PLCs are a very popular type of controllers, programmable logic controllers. Signals can be open loop or on off loop or closed loop. Closed loop provides PID based feedback mechanism. Potentiometer or encoder improves precision. Safety controls in HVAC system. Purpose of safety controls. Safety controls protect HVAC equipment from damage, occupants from hazardous conditions, the building from fire, smoke hazards. So they function by monitoring critical parameters, triggering shutdowns, alarms, or safety interlocks. So key safety devices in HVAC systems are high low pressure switch, thermal overload relay, freeze protection sensor, smoke fire detectors, flow switch, it can be water or air, carbon monoxide detector. So the first one is high low pressure switch. It cuts off compressor when abnormal refrigerant pressure. When thermal overload relay, it trips motor in case of excessive current or heat. And freeze protection sensor, it prevents coil freezing, so usually set that is approximately 4 degrees celsius. Smoke fire detectors shutdown or fans dampers, that is sense alarm signal. Flow switch, it can be water or air, verifies movement of chilled water or air. Carbon monoxide detector protects from combustion gas buildup. So fire and smoke safety controls. The function is fire smoke detectors interface with the AHUs and exhaust systems. Actions upon detection: shutdown supply and return fans, close motorized smoke dampers, trigger emergency alarms, interface with the building management system (BMS) and NFPA 90A compliance. So that is mandates automatic fan shutdown and damper closure in fire zones. So freeze protection. So purpose: protect cooling coils and chilled water pipes from freezing. So sensor thermostat can be used and thermostat mounted near coil surface. And action: so if coil temperature is lesser than 4 degrees Celsius, then stop chilled water pump, shut off AHU fan, and raise set point or initiate alarm. So high low pressure cutouts. So compressor safety is very important. And type high pressure or low pressure triggered when condenser airflow blocked, overcharge, and action to be taken for this cause is compressor shutdown. And low pressure refrigerant loss or underchange, so that is compressor shutdown to be action to be taken here. These are normally closed switches, open when unsafe pressure is detected. So flow switches are also used. Applications: water flow switch ensures water is moving in cooling coil, and airflow switch ensures fan is running before heater activation. So action is no flow detected, shutdown heating cooling, generate alarm. So emergency stop and interlocks to be provided in HVAC systems, and they are manually emergency off switch near AHU or plant rooms. Interlocks to prevent simultaneous heating and cooling, damper and fan operating in unsafe sequence. So that is emergency stop and interlocks. And smart safety in BMS. So smart in now everywhere this smart word is buzzing word, and the smart is nothing but the system that can make decision on its own. It will not depend on other controllers. So remote monitoring and logging of fault events. So predictive maintenance alerts, event based shutdown routines. So the visual dashboards and alarm interfaces. So here the category here you see the actuator, safety cutout, freezer sensor, fire safety, flow sensor, emergency shutdown. So device actuator used here in case of actuator, motorized valve and damper, safety cutout is nothing but a pressure switches, freezer sensor is nothing but thermostat, fire safety is nothing but smoke detector and damper, flow sensor is paddle type, vortex type, and emergency shutdown, push button and relay. And the function here, the modulates cooling, heating and airflow, that is motorized valve and damper, and pressure switches protects compressors, and thermostat prevents coil freezing, and smoke detector protects occupants and stops circulation, and paddle type and vortex ensures water air movement before action, and the last one is push button and relay, manual override for full system off. So this is the content of last topic, and we are completing the unit number 5 with this, and thank you for your patient learning, students, and I wish you all the best. And reference books for this particular topic, the books which are listed here are not giving much information, and I suppose this material will be more than sufficient, and no need to what you call learn more about these sensors. But in your future, if you learn about sensors, it will be very handy knowledge. You can definitely use this knowledge somewhere at some point of time. And we stop here, students. These are the references as we see in almost all sessions. There ends the syllabus, there ends fifth unit, and for any queries, you can meet me in campus, or you can approach me through our WhatsApp group. I wish you all the best in your forthcoming exam, and do well, and please be in touch till you complete the exam. Thank you, students. We stop here, and I wish you all the very best.